Good evening everyone. I am Nakushi. I am studying in class 7 in St. Thomas Residential School. Today I am going to present an experiment on the laws of reflection. When a light ray strikes on a mirror and when it reflects back is called reflection. There are three main points to be considered. 1. When the light ray which strikes on the mirror is called the incident ray and the ray which reflects back from the mirror is called the reflected ray. We take one more line which is known as the normal, which is always perpendicular to both the reflected ray and the incident ray. The angle formed by the incident ray and the normal is called the angle of incidence, and the angle formed by the reflected ray and the normal is called the angle of reflection. What are laws of reflection? There are three main points in laws of reflection. 1. The angle of incidence is always equal to the angle of reflection. 2. The reflected ray, incident ray and the normal always lie on the same plane. And 3. The incident ray is always opposite to the reflected ray. So, shall we move on to the experiment? So, the materials required are, we need one sheet of paper with a straight line in the middle. Then we need a protractor to measure the angles. Then we need a transparent container, a piece of mirror to reflect the light rays, a laser beam and a pair of cloth clips, some water and a liquid detergent.
Go.
So now we kept the protractor and taped it on the red straight line. Now we have to be very careful that the 90-degree line of the protractor should be placed directly on the red straight line. Now we will take a transparent container and place it on top of the protractor. We will take the mirror and we have to place it on the base of the protractor. So to keep the mirror upright, we used a set of cloth clips. And place it right on the base of the protractor. And now the setup is ready.
Go.
Now here I have taken a laser beam, and now if I beam it to the mirror, we will be able to see the points of the laser beam, but we are not able to see the light rays. So what we will do is, we will off the lights and check whether we will be able to see the light rays. You can see that we can see the light points more clearly, but we cannot see the light rays. So what we will do is, we will pour some water into the transparent container. Very careful not to disturb the setup. Now let's see if we are able to see the light rays. We can see the light rays, but it's very faint and not very clear. So let's see if we are able to see the light rays when the lights are off. We can see the light rays of the laser beam, but it's clear enough. So to make it more clear, we use some liquid detergent. Now we've added the liquid detergent. Let's see if we can see the laser beams. And voila, we can see the laser beams very clearly. And now let's see if we can measure them. Now I've taken 30 degrees on the protractor, and we can see that the angle of incidence is 30 degrees and the angle of reflection is also 30 degrees. Now we will take another angle. How about we take 35 degrees? And we will see that when we take 40 degrees, we can see that the angle of reflection is also 40 degrees. Now if we take 50 degrees, we can see that the angle of reflection is also 50 degrees. And now we can see that the reflected ray, the incident ray and the normal always lie on the same plane, and therefore we can say that the second law of refraction has also been proved. Now if you can see that the incident ray is always opposite to the reflected ray, and therefore the third law of reflection has also been proved. Now you must be wondering why I put the liquid detergent to the water first of all. It was because there weren't many particles in water to scatter and reflect light. So when I added the liquid detergent, it provided more particles and thus we were able to see the laser beams more visible. The liquid detergent made the water solution and gave it a colloidal effect. The rays are more visible. So this phenomenon is known as the Tyndall Effect, and it was proposed by a physicist named John Tyndall. We can do the same experiment in the medium of air. Now we are going to beam the laser light to the mirror and we will see the points of the light ray, but we are not able to see the rays. So for that I am going to use some talcum powder. So now here I have some talcum powder and I am going to blow it in the path of the light ray. We can see that the light rays were visible for one moment. And it vanishes very fast. So what happened was, there weren't many particles in the air to scatter light and reach our eyes. So when I blew the talcum powder, it provided more particles to scatter light and to reach our eyes, and thus the Tyndall effect has been applied. So in this simple experiment, I have proved the laws of refraction as well as explained the Tyndall effect. Hope you enjoyed. Thank you.